All right, folks, so this week's assignment is just sort of borrowing some ideas from the conic sections and various other things. Your task today is going to simply be to describe the ellipse, the conic section. But the issue here is we got these cross terms that we need to go ahead and get dealt with. So really, your task for today is largely going to be to deal with these cross terms. Now, we're just going to borrow ideas like we did from conic sections, and so I'm not going to change this a whole lot. I am not going to ask you to describe the Hey, Damien, you want to say hi to everybody? Hey, come here and say hello. Hey, he's playing hide and go seek now, folks. Anyway, so let me get back to this. So we're going to write it in a matrix form, x transpose A times x. In this case, we have a -3 because it's just in the equation. The idea here, folks, is we're going to borrow that conic section idea where we did the transformation. We're not going to change that. I still need you to find lambda values. I am not going to ask you to find the eigenvectors that go with it because, to be blunt, that takes a little bit too long and a little more work than I really want to do. So I'm not going to ask you to find those eigenvectors that describe the actual rotation itself. But if you want to look it up, you're going to do it. So as you remember how we wrote it, I'm going to start with the x squared, y squared, and z squared terms. So down the main diagonal, it's the x squared, the y squared, and the z squared term. So don't change that one single bit, folks. Working my way around the matrix, I do cut the cross terms in half to fill them in, just like I did with the conic section rotation. You do need to cut those things in half. So when I cut the x squared, the xy, the xz, and the yz terms in half, I get my 2, 2, and my 2. So make that happen for sure. Okay? Now, after we have done that, I'm going to go ahead and find my lambda values, and the easiest way of doing this on a three-dimensional matrix is going to be to create some zeros. So I'm going to go ahead and do some column operations and row operations to turn this into an upper triangular matrix. And once I have done that, then I can just pick the lambda values off the main diagonal and I'll be done with it. I'm pretty sure the ones that I give you for your homework assignment do not require nearly as many rotations. So don't overthink it too much, folks. So I'm going to start by doing my column operation first. Column 1 and column 3, minus column 3. Put it in column 1, create a 0. And then I'm going to do row 1 plus row 3, put it in row 3, create another 0. Negative column 3 plus column 2, put it in column 2. Now, the fact that I have that 0 up there, that's not the 0 that I wanted. I want another different 0, but it's still there. And then row 2 plus row 3, put it in row 3. There it is. I have my triangular matrix. Cross the main diagonal. Be done with that. Not a big deal, all right? So the idea now is my lambda values are going to be 2, 2, and 8. So now I'm not asking you to find the eigenvectors or eigenvectors that go with it. So I'm not asking you to describe the rotation because it's a bit more than I want to do. But nevertheless, there it is in matrix D. So my diagonal matrix 2, 2, and 8. So now that I have that, I'm just going to immediately make my substitution, okay? The substitution we make is exactly the same substitution we made with the conic section rotation. So once I have done that, I end up with 2x squared prime plus 2y squared prime plus 8z squared prime minus 3 equals 0. Move the 3 over, a little bit of division. There it is. So do not overthink this too much, folks. What I'm asking you to do is to basically find eigenvalues, make your substitution, tell me what the conic is. I am not going to ask you to describe the rotation because that's a bit more work than I want to do, but rest assured the formula for describing it does exist. It's just a bit more annoying because you have to describe it in terms of XY axis and XZ axis, and it's just a little bit more annoying. It's more work than I want to do. Anyway, if you need extra help or support, folks, you know where to find me, guys. Please make sure you get these done. You know, these are strange days, so we're just trying to make it through these, folks.